The discovery by the James Webb Space Telescope, JWST, that the universe might be experiencing a dramatic shift, possibly halting its expansion, is causing a stir in the scientific community. This stunning revelation is challenging nearly a century of cosmological models and shaking the very foundations of modern physics. For scientists, this is a turning point in how we understand the universe, and for the public, it opens up an array of daunting possibilities. If the universe is no longer expanding, does this suggest an impending end? Could the universe be heading toward a catastrophic big tear, a fatal big crunch, or a cold, lifeless big freeze? These concepts, once the realm of speculative fiction, now seem more urgent than ever as scientists around the world scramble to understand the true nature of cosmic expansion, dark matter, and dark energy. As we look at the implications of the latest data from JWST, we must ask ourselves, what does the future hold for the universe, and perhaps more unsettlingly, for humanity? At the heart of this cosmic puzzle lies the work of Edwin Hubble, whose observations in the 1920s revealed that distant galaxies are moving away from us. This was the first major clue that the universe was expanding. The implications of Hubble's work were far-reaching. Not only did it show that our galaxy, the Milky Way, was not the entire universe, but it also hinted that the cosmos itself was much larger and more dynamic than previously imagined. Hubble's observations, combined with the work of Belgian physicist Georges Lemaitre, who had independently proposed the idea of an expanding universe, eventually led to the development of the Big Bang theory. This theory posits that the universe began as a hot, dense point around 13.8 billion years ago and has been expanding ever since. But the expansion of the universe is not a simple, uniform process. Initially, scientists believed the universe was expanding at a steady rate, but further observations, particularly in the late 1990s, revealed that the expansion was accelerating. This led to the introduction of dark energy, a mysterious force that is believed to be driving this accelerated expansion. Dark energy is thought to make up around 70% of the universe's total energy content, but its true nature remains one of the greatest unsolved mysteries in physics. While dark matter accounts for 27% of the universe's mass energy, dark energy's role seems to be far more influential in shaping the large-scale structure of the cosmos. For nearly a century, this model, Hubble's law of expansion, combined with the theories of general relativity and the mysterious forces of dark matter and dark energy, has been the bedrock of our understanding of the cosmos. However, the data from the JWST is calling this model into question. The discoveries made by the telescope indicate that the expansion of the universe may not be as straightforward as previously thought. In some regions of the universe, the expected expansion appears to be slowing down or even ceasing altogether. The very fabric of spacetime, which we once believed to be expanding uniformly, is now showing signs of behaving in complex, unpredictable ways. This unexpected shift has left scientists scrambling to explain the implications of these findings. If the universe is no longer expanding, or if its expansion is decelerating, what does this mean for the future of the cosmos? Could this signal the end of the universe as we know it? Could the universe eventually collapse in on itself, or could it continue expanding forever, becoming a cold, empty expanse devoid of stars and galaxies? These are not just hypothetical questions anymore, they are questions that we may soon need to answer. The idea of a universe that stops expanding, or even begins to contract, brings us to the possibility of the Big Crunch. This is one of the most well-known and long-debated theories about the ultimate fate of the universe. In the Big Crunch scenario, the gravitational pull of the universe's matter eventually overcomes the force of its expansion, causing it to collapse back on itself. All galaxies, stars, and planets would be drawn toward a single point, and the universe would become increasingly hot and dense. Eventually, this collapse would result in a singularity, a point of infinite density, similar to the conditions that existed at the moment of the Big Bang. While the Big Crunch was once considered a plausible end to the universe, it became less likely when the discovery of accelerated expansion led to the idea of dark energy, which seemed to counteract gravity's pull. Yet, if JWST's findings indicate that the expansion of the universe is slowing or stopping, it's possible that this old theory may need to be reconsidered. On the other hand, we have the possibility of the Big Freeze. This is another potential fate of the universe, and it is perhaps the most chilling. In this scenario, the universe continues to expand forever, but at an ever-decreasing rate. As galaxies move farther apart, the amount of available energy decreases. Stars burn out, and eventually, the universe becomes a cold, dark, and lifeless place. The Big Freeze is the ultimate end of the universe in the sense that it reaches a state of thermodynamic equilibrium, where no work can be done and no processes can continue. This would be a universe that is frozen in time, an endless void with no possibility of new stars or life forming. But then there is the Big Tear, a much more violent and sudden end to the universe. In this scenario, the expansion of the universe accelerates to such an extreme degree that it tears apart everything in its path. First, galaxies would be ripped apart, followed by solar systems, stars, planets, and eventually atoms themselves. The forces driving this acceleration are tied to dark energy, and if this force continues to grow stronger, the universe could eventually reach a point where the very structure of matter is destroyed. The Big Tear is a catastrophic end, where the universe reaches a point of no return and everything is torn apart by the ever-accelerating expansion. These ideas might sound like science fiction, but they are grounded in real scientific theories that depend on what we currently understand about cosmology and physics. But what if our current understanding is incomplete? What if we've been wrong about some of the most fundamental aspects of the universe's behavior? What if the mysteries of dark energy and dark matter are even more profound than we realize? The latest findings from the James Webb Space Telescope are forcing us to confront these uncomfortable questions. The evidence from JWST suggests that some of the assumptions we've relied on for decades might need to be revisited. One key aspect of this is the nature of dark energy itself. If the expansion of the universe is slowing down, or if it's behaving in unpredictable ways, this could mean that our understanding of dark energy is fundamentally flawed. Perhaps dark energy is not a constant force, but one that varies over time or space. If this is the case, it would have profound implications for the future of the universe. Could the universe have been expanding in a more complex, irregular way all along? Could the expansion stop in some places while continuing in others, much like a whirlpool, where some areas of space are stretched and others are compressed? These are the kinds of questions that scientists are now grappling with as they try to make sense of the latest data. Another possibility is that we are misinterpreting the nature of the universe's expansion itself. Perhaps the expansion we have observed is not a simple, uniform process, but rather one that is influenced by a variety of factors that we don't yet fully understand. It's also possible that our models of gravity and space-time need to be rethought entirely. Some physicists have proposed alternative theories, such as the idea of holographic gravity, which suggests that gravity is not a fundamental force but emerges from the principles of quantum mechanics. This idea could fundamentally change the way we view the universe and its ultimate fate. As we face these new revelations, we must also consider the possibility of a multiverse. Some versions of cosmological theory, particularly those involving inflation and eternal expansion, suggest that our universe is just one of many bubble universes, each with its own laws of physics and conditions. In this model, the universe would not have a definitive beginning or end. Instead, it would be part of a never-ending process of creation and destruction, with new universes constantly popping into existence. The concept of a multiverse challenges everything we know about the universe and forces us to reconsider our place in the cosmos. At this moment, the field of cosmology is at a crossroads. The revelations from the James Webb Space Telescope are pushing scientists to reconsider the very structure of the universe. Are we on the verge of a major breakthrough, or have we been operating under false assumptions for nearly a century? The data that JWST is providing might be the key to unlocking these mysteries, but it may also reveal that our understanding of the universe is even more incomplete than we ever imagined. As researchers continue to analyze the telescope's findings, one thing is certain: the universe is far stranger, more complex, and more mysterious than we could have ever dreamed. Whether we are approaching the end of everything or a new era of discovery, the journey to understand the cosmos is only just beginning.